Okay, this is the first screencast for AP Chemistry, Chapter 1, and generally I'll try to keep these to about 10 minutes or so, but this one I'm going to try to just rip through in one shot, so however long it is, that's how long it's going to be. So this is a lot of review. These first 4 chapters we're going to go through pretty quickly. This is Chapter 1, so a lot of this is just going to be really basic review for you. So obviously, looking at chemistry, it is the study of matter and its properties, typically like energy and such, but we'll plug through that. Matter, we decide is anything that has mass and also takes up space. And you can look through some different examples of that. Looking at matter, we can subdivide that into things that are like atoms, and that's what we can break down into its smallest parts, still retaining the properties of that substance. And then there's examples of atoms. There's about 118 of them. Pretty close. Some are more defined than others. But we have 118 of these elements, and they all have their very distinct properties. And if you start putting a couple different elements together, you get what are called compounds. Not meaning to cross that out, but compounds. States of matter, as you can see there, solid, liquid, and gas. The one we'd kind of leave out here is plasma. That's what most of the universe is made of. It's an ionized gas, but we will probably never mention it again outside of what we just did. So as far as classifying it, you can go through this little flow chart and pick out what you're looking for. I'm not going to go through all steps. You can go through that on your own. It's in the PowerPoint, which I also leave on the web page. Changes and properties, and changes in matter, excuse me. So types of properties, these two kind of have 2 different groupings in which we'll list them here. Chemical and physical properties and chemical and physical changes. The main thing you want to keep track of that is whenever you're talking about something that's a physical property or a change, is you always keep whatever you started with. So let's use water as an example. If I boil water, I still have water. If I take a measurement of density, mass, whatever you like, you always still have that substance, in this case, water. Chemical properties means you're changing whatever you had. So whatever you started with, you will not have when you're done with the experiment. So if you want to go to gasoline, I want to check the flammability of gasoline when I am done with that observation, change, whatever you like. I no longer have gasoline. It's now something new. So that's the question you have to ask yourself when you're doing this is, do I still have that same substance? Intensive and extensive properties. If you have an intensive property, that substance can be measured or looked at. And again, you still retain that property, I guess. So for example, with water, it doesn't matter how much I have. I could have a gram of water, or I could have 2 kilograms of water. It doesn't matter. The density won't change. That measurement will stay the same. The boiling point of water is always 100 degrees Celsius. Doesn't matter if I have a little or a lot, it's always the same, which is different than an extensive property, which will vary based upon how much I have. So for example, the mass changes. If you add more water, the mass will change. So some things are extensive, which means they will change, and some things are intensive, they stay the same. Okay, moving on. Physical and chemical changes, we kind of went over with the properties, so I won't repeat that. Reactions. In the course of a reaction, you're going to have a combination of elements. This is the basis of what we're going to be doing. If I mix some hydrogen gas and some oxygen gas, we can predict what we will get based on their properties and how much we will actually produce, which is pretty cool. We'll do a whole bunch of that. Separations of mixtures will actually run a lab very similar to this here. There's several different ways we can separate things. One is called a filtration, which you're physically just separating them with some type of a membrane. You can do a distillation. I don't think we're going to do any distillations in here. This is more organic chemistry. But as an example, just to show this one here, in this flask here, we could have 2 substances. Let's call it ethyl alcohol and water. Ethyl alcohol boils somewhere around 78 degrees Fahrenheit, or excuse me, Celsius, and water boils at 100. So if we gently heat this flask of solution up, we can get the ethanol to boil off at 78, hold the temperature there, and after a period of time, the liquid will no longer boil. All of the ethanol will have been driven out, and then in this part of the column here, there's cool water running through a double-lined container, and it'll cool down the ethanol. We can collect it over here. And the water will be remaining over on this side, and the ethanol remaining over on this side. So just one example of how we could do that. Chromatography, I think we're also going to run this lab. This is a means of separating substances based on their polarity. So if you have a non-polar solution, and this happens to be a polar strip or substance, we can separate these substances out based on their differences in the polarity. So basically you have to have a polar versus non-polar mixture. Units of measurement, these are the SI units for most everything we would ever measure in a science classroom. Many of these you will be familiar with from your chemistry class. If you've taken physics, you may have used amps. I doubt in any class you've actually used candela, but it's out there as well. As far as units of measurement for the metric system, this is a lot of the ones we will use, and actually we'll use some of them. So for example, a little bit of mega, kilo, we're actually leaving a whole bunch out here which we typically didn't use, but you had to measure or remember hecto. We never use it. Deci we probably won't use much. Centi of course, milli of course, micro yes, maybe a little nano, and the rest of these probably not. But it would be fun to use zepto, wouldn't it? Volume. Volume you should be fairly familiar with. The main two units of measurement we'll use for that would be liters and milliliters. And just remember that a liter is made up of 1,000. Thousands and tens are typically, we're going to look at differences in measurements here. Just a little fun fact here as far as how the metric system is kind of lined up is water. Everything's kind of based on water. So for example, 1 gram of water is equal to 1 centimeter cubed of water, which also has a volume of 1 milliliter. And there's some other little measurements we can use there as far as energy goes, but we'll do that another time. Just looking at temperature again, these are the 3 scales we have in here. We will really never ever use Fahrenheit. It's the only time we'd ever mention it. It's just so we can kind of relate it to something that we know really well. But we'll use quite a bit of Kelvin and Celsius. And you can read through that. But we know that water boils at 100, freezes at 0 Celsius. If you need to change over to Kelvin, just add 273 to whatever Celsius temperature you have, and you're all set. But the nice thing about Celsius and Kelvin is degree, it's all the same. 5 degrees change in Celsius is 5 degrees change in Kelvin. So it works out really nice. And Fahrenheit, I'm not even going to mention. We'll maybe talk about it in class sometime. Density you're familiar with as far as looking at units of that. It's simply mass over volume. And if you ever get really confused in that, the way I've kind of talked about before is mass over volume. Kind of looks like a nice little heart. Isn't that nice? And that's equal to density. And again, you have to manipulate these around a little bit. If I have to solve for mass, I have to multiply both sides times volume. Uncertainty in measure. Depending on what you're measuring, you have to use different types of equipment. So for example, if I want to measure something to the nearest milliliter, I'm probably not going to use a volumetric flask because that usually measures to 250, 500, or 1,000 milliliters, and it's not useful. So you have to make sure you're using what is most appropriate for what you're trying to determine. Sig figs. Be honest, I'm not a huge stickler on sig figs, but it is important. It doesn't have a huge impact on the exam, AP exam, but it is something, if I give you, a couple of numbers to measure out, you should not give me some answer which is 0.012782381 because you set your calculator to give me all those numbers. If it only gave you 2 sig figs, which would be right in here, then your answer should end right in there. The second sig fig, there's a 1 in here that I knocked out. But your numbers should represent what your calculations or original numbers gave you. All right, I know I'm over the edge here a little bit, so I'm going to keep on going. Just get this done. As far as what you should be measuring with sig figs, non-zeros are significance. Zeros between significant numbers are significant themselves as well. Leading zeros, nope. So for example, if I have 0.001, that's 1 sig fig. But if I throw a 0 on the end here, theoretically I've measured that 0, so I have 2 sig figs. So a slight difference there. When you're doing some calculations, if you're doing adding or subtracting, you're looking at decimal numbers within your calculations, and the one with the least number of decimals is the significance. If you're multiplying, whichever one has the least number of sig figs, that determines what I report in the answer. Precision and accuracy. Precision means you've grouped your measurements together really well, but you could have terrible accuracy. So in this scenario here, this person's a great shot, but they missed every time. And if just because you're accurate doesn't necessarily mean you did a good job. So if I round all these answers together here, I hit the bullseye, but none of them actually hit itself. So to be accurate, yeah, I guess the more shots you take, if the average hits the bullseye, that's fine, but not necessarily does it mean that you did a good job. It just means that's, ultimately what you want to have is good precision and accuracy. And moving on to dimensional analysis. We won't spend a whole lot of time on this because it's better done in class, but you can kind of see we need to be able to convert from one unit to another just so we can make changes in what information we had to the information we want to get to. We'll do lots and lots of dimension analysis, and you'll get really good at it. Just kind of showing one method of going through there, but again, we'll do this in class. And that's the end of lecture number 1.